We are on page 12 in the notes. Go say hello. Okay, wonderful. They're saying hello to you if you're watching at home. Wonderful. Okay, that's weird. So, yesterday we looked at two different methods for solving quadratic equations, factoring, square roots. Both methods were a little limited. We can only solve by factoring if you can factor. We can only solve by square roots if what's the case? B equals 0. I told you there were two other methods that will always work, but they're a little bit more involved. We're going to start looking at one of them today called completing the square, and I will warn you that today is going to take a little bit of extra focus. I think that what we're doing today and tomorrow is some of the more difficult stuff in Algebra 2. So it's just going to take some focus, and we'll get through all that. And then you have, I think you've seen this before, but I also think it's been a while, and I am not convinced you're going to remember that.
I was pretty good at this stuff.
Okay, then you should be pretty good this time. Here's what I want you to do. Okay, so here's what I want you to do. We're on page, what page are we on? We're on page 12. I would like you, on the top of that page, it says to factor that thing. Go factor that. There's nothing weird. Just go factor. X squared plus 10x plus 25. Get rid of these. Hands to tell me the factoring. Aiden.
X plus 5 times x plus 5.
Perfect. Multiply to 25, add to 10. I know this is positive, so they have the same sign. This is positive, so they're both pluses. X plus 5, x plus 5. Now, I showed you something like this earlier and told you there's another way we could write this. Ariana, what can we do? Good. Right, but she was raising her hand, which is why I called on her. We can.
I can't tell.
I know. I will do a better job of telling you when I need you to raise your hand. This factors into x plus 5 in parentheses squared. Today, we are going to spend all of today and all of tomorrow looking at things that factor into a single term squared. We call the original problem, x squared plus 10x plus 25, a perfect square trinomial. Try 3 pieces, 3 terms, is a perfect square trinomial if it can be factored into a single term squared. A perfect square trinomial can be factored into just one term squared. So x squared plus 10x plus 25 is an example of a perfect square trinomial, because I could factor it into x plus 5 in parentheses squared, which I know works because if I FOIL x plus 5, I get my whole x squared plus 10x plus 25 thing. Now, there is a rule for figuring out if the original problem is a perfect square trinomial. I would like you to look at the 10 and the 25. What's half of 10? How can you take that and make it into 25? Or also squaring things. We are going to have a perfect square trinomial if our constant is half the middle number squared. We are going to have a perfect square trinomial if our constant is half the middle number, b over 2, and then square it. I know I have one at the top because half of 10 is 2. Squared is 25. That's my little shortcut way of looking at any problem and knowing if it is a perfect square trinomial. Half the middle number squared. Then, wait a moment. Then there's a shortcut for actually factoring it in and of itself. This number was 10, half of that is 5. My factor was just x plus 5 in parentheses squared. If I have a perfect square trinomial, it's going to factor into x and then whatever half that middle number was before doing my squaring. This is going to get factored into x plus half that middle number, square the entire set of parentheses, which means we would write it out twice in FOIL if we were actually doing things here. Yes, if there's a 1 before the x squared. We will find a way around that tomorrow, but for right now, just if There's a 1 before the x squared. Just x squared. Tomorrow will be 2x squared, 3x squared. Today, by the end of today, you will be able to solve any quadratic equation that starts with a 1 before the x squared. Tomorrow we'll generalize that. Okay, so I'd like to take a look at these things over here. In letter A, I want to first figure out, is this even a perfect square trinomial? Your middle term is negative 8. What is half of negative 8?
4.
It's not 4.
Negative 4.
Negative 4. And what is negative 4 squared? Is it a perfect square trinomial? Is my last number half the middle term squared? It is. Therefore, I can factor this into x something. That term is squared. The something is just half my middle number before doing any squaring, which is what? If you don't believe this is correct, what does x minus 4 squared really mean?
X minus 4 times
X minus 4, x minus 4, and if you FOIL that out, you will get the original thing back. That's what we're really doing, but it's a kind of a shortcut for factoring those special things. Is this a perfect squared trinomial?
Yes.
Why?
Because half of 12 is 6.
Half of 12 is 6. Good. And I am going to write it out just so we see half of 12 is 6. Squared gives me 36. Yep, everything worked there. So I can use that shortcut to factor it. It's going to be x and then something.
Plus
Yeah.
6.
Plus 6. X, and then half your middle term. Half my middle term was positive 6, so x plus 6 in parentheses squared. This looks unpleasant. Let's see what happens, though. What is half of negative 3, by the way? No decimals. I want fractions, and not mixed number fractions, improper fractions. It's going to be easier. What's half of negative 3? Let's just say negative 3 over 2. How do you square a fraction? Square the top. What's negative 3 squared? What's 2 squared? This looks weird, but is it a perfect squared trinomial? Yeah, it is. Now, I'm going to factor it. What's the number with the x? X minus 3 over 2. It's x and half the middle term before we do any squaring. That thing in parentheses squared. Even though it's a fraction, not so terrible. Next. This method we're about to learn is called completing the square. I am giving you things on the bottom that are not yet perfect square trinomials. I want to first complete it to make it a perfect square trinomial. And then once it is one, I want to factor things. So here's what I mean. X squared plus 2x plus, I didn't tell you the last number. Raise your hand if you think you can tell me what that last number must be. Is that a hand, Elena? Why? Sure, same thing we were doing. What's half our middle number? Well, half of 2 is 1. Squared gives us 1. So I'm going to complete that by putting a 1 at the end. I think you can now go factor that thing using our little shortcut pattern for factoring because it's now a perfect square trinomial. It's going to become one single piece in parentheses squared. Erica? X plus 1 squared. You don't believe me? Do x plus 1, FOIL it out. Yeah, you'll get the original thing back. I want to see if you can do the next two. Figure out what is the missing piece, so go complete that perfect square trinomial, and then factor it. Yep. Half the middle number squared is what goes at the end. Half the middle number is what goes in the factor. Those are really the two things we have to remember for this whole section, today and tomorrow. Jake, what's going in at the end over here? 36. You need to be doing half of negative 12. Okay, half of negative 12 is negative 6. I'm going to square that. By the way, this last number, will it always be positive or could it be negative? Why, Erica?
Because whatever you're squaring is in parentheses.
Yeah, if you're squaring something, doesn't that have to give you a positive answer? So it's always going to be plus at the end. Okay. Will the factor always be plus? No, because that's just like whatever half the middle number is. So, Ryan, do you have the factoring for B?
X minus
Perfect, exactly. X, and then half the middle number, half of negative 12 is negative 6. I'm going to square that. Again, if you don't believe this, write out x minus 6, and FOIL. You'll get the original thing back. Question, Ariana? You've got this look like maybe there's a question. No, you don't. Okay, never mind. Sorry. Do you have C? Do you have the number for C? It's unpleasant.
Yeah, I got 25.
Yeah.
Over 4.
So I need to do half the middle number, 5 halves squared. Square the 5, 25. Square the 2, 4. What in the problem tells you you're going to get a fraction? If you have an odd number in the middle. So we're going to see a couple of those, and anytime we have an odd number in the middle, we're going to get a fraction. Whatever, they're not really that terrible. We're going to factor. Caitlin. X plus 5 over 2 squared. And again, as I keep saying, if you write this thing out, I know it's going to be unpleasant with the fraction, but if you write it out twice in FOIL, yeah, you would get that original thing back. Any questions so far?
No.
You're with me?
No.
What are you answering no to? No to, do you have a question, or no, you're not following me? Wonderful, turn the page. Oh my goodness, of all days. Okay. Next. This was really just getting us into what we're about to do. We are now going to solve these quadratic equations by this new method called completing the square, although I'm not totally ready to do that yet. I'd like to look at letter A. Does anyone notice anything interesting about x squared plus 10x plus 25? Okay, not set equal to 0. I was actually deliberate with that. X squared plus... Aha! That's kind of convenient. I gave you a perfect square trinomial.
That's the same one we just did.
Perfect, okay. And so you'd better then know how to factor that. How do you factor that? Ignore the 4. Ignore the 4 for now. I don't. Hold on to that for a moment. Right now, I have a perfect square trinomial. I think if I made it equal 0, I wouldn't have that anymore. So, raising your hand, how do we factor x squared plus 10x plus 25? Aiden. X plus 5 in parentheses squared, because I know half of 10 is 5 squared is 25. I know it's a perfect square trinomial, so I know I can factor it into x and then half the middle number before doing any squaring. Okay, watch this fancy thing I can do now. I turned this problem into a single term squared. How do you get rid of a square? You're half right. Plus or minus the square root. I'm going to go and I'm going to take the plus or minus square root of both sides. I'm going to get x plus 5 equals plus or minus the square root of 4. Plus or minus 2. I'm going to get x plus 5 equals plus or minus 2. How would you get x by itself? Subtract 5. Now, this is important. 2 minus 5 is different than negative 2 minus 5. Don't do anything with the 2. I'm going to stick the negative 5 before the plus or minus, and I'm going to say x equals negative 5 plus or minus 2. Almost. Let's just do it. What's negative 5 plus 2? Negative 3. What's negative 5 minus 2? Your answers are negative 3. Whoops. Let me write it over here. X equals negative 3 and negative 7. Sean. Okay, but so hold on to that for a moment, because letter A, we would have been able to solve that by factoring. Letter B, factoring wouldn't have worked there, and actually no other method we've already learned will work, so this method is going to be the only way we could do letter B. In letter B, do you also notice that the left side's kind of nice? Okay, how does that factor? X minus 4 in parentheses squared. I know half the middle term is negative 4 squared is 16, so yeah, it's a perfect square trinomial. I can factor this into x minus 4 in parentheses squared equals negative 7. How do you get rid of the square? Plus or minus your square root. X minus 4 equals plus or minus the square root of negative 7. Take out an I. So x minus 4 equals plus or minus I root 7. How are you finishing? Plus 4, plus 4. We're going to show that algebra, and we're going to get x equals 4 plus or minus I root 7. This is not an equation we would have been able to solve by factoring. I said that wrong. X equals 4. No, sorry, I said it right. X equals 4 plus or minus I root 7. The 4 is going to go before your plus or minus. And that's going to make a difference. I have two answers here. One answer, I don't need to see this, but the two answers are 4 plus I root 7, that's one, and 4 minus I root 7, that's the other. I don't need to see it written out like that. You can leave it like that. Square roots by themselves wouldn't have worked in letter B. Solving by factoring wouldn't have worked in letter B. This method will work there. Now, there's a major problem with this. I was so nice with what I gave you in A and B. What's the problem?
It's inefficient.
That's not the problem. You think I'm always going to give you a perfect square trinomial? No. So the problem with solving this way only works if we have a perfect square trinomial. Oh, maybe not. Okay. Let me find another pen that works. Only works if we have a perfect square trinomial. And I think if you look at the box on the bottom, is it good? No. Okay. Didn't I tell you, though, this method's always going to work? So we've got to have a way around that I gave you a nice problem thing to make this work with any problem. Okay. This is going to take some focus and concentration. By the way, there's actually two reasons we're learning how to do this. Yes, we're learning how to do this because we can solve quadratic equations this way, and I will need to be able to test you on, can you solve by this method? But this particular factoring we're about to see will be used for other things in other units. So we actually do need to use this method, even though I know you also know there's a quadratic formula coming up that can be used with these problems. That won't help us with the special factoring we'll have to do with parabolas in the next chapter. Completing the square is the method so we are going to have to learn this method. First of all, I want to solve this thing. You told me right away that it's not nice because what would the number at the end have to be if it was nice? What would the number have to be? 64? And it's not. It's negative 36. First thing we need to do, I need to rearrange things in this problem. I actually don't like that it equals 0. I want the x's on one side and the constant on the other side. So step number 1 is going to be get the x's on one side and the constant on the other. Sean and Erica and you people, can you see or do I need to make this bigger? Did you say bigger? I'm good? Yes? Ryan, all the way in the corner, you're okay? Get the x's on one side and the constant on the other. And throughout this entire process, we're going to need to make sure we show all of the algebra that we're doing. This is also about the idea of how can I transform this into something I can get answers out of. So raising your hand, what algebra am I talking about doing first? Raising your hands. Only one person can tell me algebra? Vitor. I'll give other people a chance. Add 36 to which side? Yeah, you're half right. Don't we need to add it to both sides? Yes. I think that's probably what you meant. But yeah, you're going to show me plus 36 on both sides. That's the whole point of like equation solving. What we do on one side, we do to the other. And we're going to get x squared minus 8x equals 36. Here's where the magic happens. I need to turn that left side into a perfect square trinomial. It is not right now, but I feel like I could add something onto that side to make it a perfect square trinomial. Step number 2, I am going to say, make the left into a perfect square trinomial. I'll add in more details in a moment. But we are going to make the left into a perfect square trinomial. What would you have to add to that side? 16, why, Marcus? Why 16? Perfect. Half your middle number is negative 4. Square root is 16. I'll use a different color there. Are you allowed to do that? Just like stick a 16 on one side? Thank you. The whole point of equation solving is whatever you do to one side, you do to the other side. So I'm going to add 16 on the left, but I have to do the same thing on the right. Step number 2, make the left into a perfect square trinomial. I'm going to say in parentheses, by adding half my middle number squared, not just to that side, but to both sides. And I feel like now it's actually going to be very similar to what I was doing at the top, because now I finally have a perfect square trinomial. Step 3, I'm going to factor. Hands to tell me x squared minus 8x plus 16, what that gets factored into. Because we can use our shortcut now that it's a perfect square trinomial. Dumb. X minus 4 in parentheses squared. Write it out twice in foil, you'll get the original back. What should I say on the right side? Yeah, what? 52. Actually do the addition. I'm going to make step 3 factor into, again, we have that shortcut we can use, x, and then half the middle term, squared. Raising your hand, what's going to happen next? Raising your hand, what is next? Erica, what's next? You're half right. Take the plus or minus square root of both sides. That's how I'm getting my 2 answers out of this. Take the plus or minus square root of both sides. So I'm going to get x minus 4 equals plus or minus the square root of 52. Yep, I'm going to need all this work. These take a while. That's why you're not going to have 50 problems to do tonight. Then I have 2 last steps. I'm going to simplify and solve for x. Finally, I'm going to simplify my root. I'm going to show all the breaking down and simplify that thing, and then I'll get the x by itself. So what are you going to do with root 52? Yeah, so what was the breaking down? 4 times 13, perfect. Plus or minus 4 times 13. Remember with the plus or minus thing, that's coming at the very front, so I'm going to say plus or minus 2 root 13 over there. I'm going to add 4 to both sides. Should I add the 4 to the 2? No, it's not really 2. It's really 2 plus or minus root 13. It's really 2 root 13. No, the 4 is going before it, and I'm going to say 4 plus or minus 2 root 13. There's a lot that goes into this. We are going to do a few more together. I promise by the time we leave today, we'll be in okay shape. But this takes a little while to get used to. And tonight in the homework, it is going to be really, really important that you have these notes in front of you as a model. It's third period. You've got 2 more classes. You've got plenty of other things you're going to learn about. You're going to forget all these steps. Have these notes in front of you tonight. I want to do letter A with you. Turn the page. But I'll wait a moment. Are you set, Brendan? Anyone else still making notes? Okay. Letter A. Here we go. Maddie, what's step 1? Before that. Wait, hold on. Were you saying find the perfect? There's something before that. It's not actually in the right form. Yeah, so do what? 41 from both sides. Okay. Minus 41, minus 41. X squared plus 6x equals negative 41. Now, Maddie, I'm ready for what you're about to say. What are you going to add? So now I'm ready to do that find the perfect square thing. What should we add to both sides? What is the perfect square that I'm going to... Sorry if I'm putting you on the spot.
I have no clue what
Okay, so we now need to do that perfect square thing. I need to make this a perfect square trinomial. I need to add some number on the left and on the right. That's what I'm asking.
okay.
What is that number?
It's 9.
And why?
Because 6 divided by 2 is 3. 3 squared is
Perfect. You need to go do half your middle number. Sorry for putting you on the spot like that. Half your middle number is 3. Squared gives us 9. I'm going to stick a 9 over there and a 9 on the other side. It is actually really easy to forget to do it on both sides, which is going to totally throw off your numbers and make it very wrong. Make sure it's going on both sides. I find it helpful to actually write that little space on both sides because then I know I've got to fill it in. Okay, now we're going to factor. It's going to become a single term in parentheses squared. X, and then what? Anyone. Plus 3. Half your middle number before we do our squaring. So x plus 3 in parentheses squared. Equals what?
32.
Negative 32. I think I want to see if you can finish this. You go do your plus or minus square root, break it down, and get the x by itself. Please don't go on to b. What's your problem over there? Oh, we're on page 14.
No, I'm just saying.
Not today. Tomorrow. Oh my goodness. Have you finished letter A?
Not yet.
Well,
It's really confusing.
what part are you confused by?
The whole process itself makes sense, but I don't know. I just can't figure out x plus 3 equals plus or minus negative 32. The simple part is tripping me out.
Okay. First thing, I see a negative. What's coming out of the roots?
I.
Okay. Next, we need to break down 32. We need to go back to our list of perfect squares. What perfect square is inside 32?
16 and 2.
16 and 2. If you said 4 and 8, that would also work, but you'd have to do it a second time on the 8. 16 and 2 will get us there quicker. I'm getting plus or minus 4I root 2. So I've got x plus... hold on, not there yet. You okay with that plus or minus 4I root 2?
Yeah.
Okay. Normal algebra, how do we get rid of the plus 3? We subtract. Okay. I'm going to do minus 3 minus 3. I cannot do 4I root 2 minus 3. That's not going to give me anything. I'm going to stick this before the plus or minus. I'm going to say x equals negative 3 plus or minus 4I root 2. My two answers are the two complex numbers, negative 3 plus 4I root 2 and negative 3 minus 4I root 2. This is not on tomorrow's quiz. Letter B. First step. Fix it how? What? Be more specific.
7x and 5. No, actually, 7x.
Subtract 7x from both sides and make sure I'm seeing minus 7x minus 7x. Oh, if this is confusing, this is probably not the best time to be leaving. I mean, I really don't think so. Okay, hold on. I think this problem is going to be a little tougher. Why? It's going to be a fraction. And again, what in the problem tells you it's going to be a fraction? It's an odd number in the middle. Anytime the middle is odd, we're going to get a fraction. Okay, well, let's go. Half that middle number squared. What are we going to add? I think I want to do this entire one together. Square the top and square the bottom. So what's negative 7 squared? Whoa. Negative times a negative gives you a positive. So 49 over 4. And I'm going to do 49 over 4 over there. So hold on a moment. All I've done so far, I moved things a little bit. That shouldn't be a big deal. I'm getting x squared minus 7x plus 49 fourths. 80. No, it's actually going to be a lot easier as fractions. Plus, by the time we're done, we're going to want to give exact answers, and once you start getting into decimals, that's going to be a problem. Next, the left side. Let's deal with the left, because I think that's actually not super hard because we have a little formula we can use. X, and then what with the x inside the parentheses? Plus or minus? Minus, because that was what I had over there. X minus 7 halves. On the right side, how do you add 5 and 49 fourths, Marcus? Common denominator. Go get a common denominator. 20 over 4. Good. We should be getting 24 fourths plus 49 over 4, 69 over 4 for our fraction. Please excuse me. Now, I'm going to do my plus or minus the square root. X minus 7 halves equals plus or minus. These are actually both going to be good in two different ways. What's the square root of your denominator? 2. That's not bad. What's the square root of the numerator? What can you do with that? What was that? Nothing. So what are you going to say? You're just going to leave that. That's why I said it was good. We don't actually have anything to do with this. Actually, often, you're going to end up with numbers that can't get broken down. That's a good thing. One last step. How? Plus 7 over 2 to both sides. I'm going to say plus 7 halves. I'm going to say plus 7 halves. I'm running out of room, so x equals 7 halves, plus or minus root 69 over 2. If you would prefer to have one big fraction, I guess since they have a common denominator, I guess we could also say, I'm fine with this for an answer, but hold on one second. I guess we could also say this, all over 2. Either way is fine. Sean, question. It will be on a quiz. It will not be on tomorrow's quiz. I feel like I've answered that a couple times already. I would like you, right now, possibly talking with someone next to you for some help, to see what you can do in C and D. Actually, you know what? I can look at these right away. I think one of them is going to be not so bad. I think one's going to give me fractions. Which one's going to give me fractions? Why? Odd number in the middle. See what you can do, and you're welcome to talk with someone near you, and definitely use A and B on the previous page as models with these. See what we can do in C and D.
The number is too small,
If the numbers are big, we complain. If the numbers are small, we complain.
Yeah.
Oh my gosh. See what you can do. I think C was actually already in a nice order. You don't have to move things from side to side.
Yeah.
So I was good with that at least.
Right, so what's half of negative 2 squared? 1. Negative 1. Oh no, what's square? What half? My brain hurts. Let's go back to my notes. So negative 2 over 2 squared is 112. There's 1.
Okay, half my middle number is negative 1 squared. Did you get positive 1 added to both sides?
Yeah. Yeah. That's what I did.
Numbers are so small.
I'm going to factor, and I'm going to get x minus 1 in parentheses squared equals negative 1.
Wait, you get a fraction for this?
I'm going to do my plus or minus the square root. I'm getting plus or minus root negative 1. Let's talk about C, then I'll give you more time on D. I'm getting square root of negative 1. What is that? Oh, by the way, I feel like that may even be a question on your cumulative review. What is I? What is I? Square root of negative 1. That was also a test question. It was a multiple choice test question. X minus 1 equals plus or minus I. And then, now it's easy. Plus 1 plus 1. See what you can do. Working with a partner if necessary on D, but please see what we can do. I think D is going to look very similar to the work we did in letter B.
And there's fractions.
Marcus, half the middle term squared. That's a No, whoa, 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 whoa. You're thinking square root, you're not thinking division. 9 divided by 2 is 9 halves. That's where those fractions are coming from.
Would we ever have an answer that would have
Two roots? No, because the whole point is you're getting something inside your root that's a good number.
two x's?
2 x's.
I'm really
Okay. Let's start to go through letter D. I'm adding 3 to both sides. That shouldn't have been the tough part. Now. So now. Put the chair on the floor. Thank you. I need to do half my middle number squared. I'm going to write this out. Half of 9 is what? Don't think too hard. 9 over 2. Don't convert it to a decimal. Leave it as a fraction. It makes it easier to square. What is 9 halves squared? 81 over 4. I'm going to add that to both sides. I'm going to factor the left. Hold on. I'm going to factor the left x, and then what's in the parentheses? Plus 9 over 2. Half that middle number before we did our squaring, so x plus 9 halves. On the right, you need to take a moment and get a common denominator. You need to do 3 over 1 plus 81 over 4. I think common denominator is 4. I think that sounds good. Didn't I say that? Yeah. There's a lot going on here. Just wait till tomorrow. Oh, sorry, I didn't say that.
Actually, no, the quadratic formula is
So, I'm getting 93 fourths. Did anyone else get that? 93 fourths? Okay. I think we're done with the tough parts here. What's the next thing we do? Plus or minus your square root. X plus 9 halves equals plus or minus. I'm just going to go straight to square root of the top over square root of the bottom. They're both nice, once again.
They're both nice.
What's the square root of 93? Well, what is it? Square root of 93 is the square root of 93. Square root of 4 is 2, so root 93 over 2. Last step. Get the x by itself. How do we get rid of that plus 9 halves? Of course. Minus 9 halves, minus 9 halves. Hold on. We're going to get x equals negative 9 halves. Hold on a moment, because I need to talk to you about a few things. Square root of 93 over 2. What should you have in front of you when you do the homework tonight? Your notes. Couple comments. I am going to need to